So now we see the problems based on photoelectric effect. So we know the photoelectric effect means the ejection of electrons from a metal surface by passing a beam of light on it with a suitable frequency. So here the problem, in a photoelectric effect experiment, irradiation of a metal with light of a frequency means the light fall on the metal surface having the frequency 5.2 into 10 power 14 second inverse, nothing but hertz, and the yield electrons with maximum kinetic energy means the ejected electrons are having 1.3 into 10 power minus 19 joules of maximum kinetic energy. Simply, we need to calculate the threshold frequency of the metal. So, what is meant by threshold frequency here? Threshold frequency means the minimum amount of frequency or the minimum frequency required to eject the electron from a metal surface. A metal surface పై నుంచి ఎలక్ట్రాన్స్ ఎజెక్ట్ చేయడానికి అవసరమైన మినిమం ఎనర్జీని ఏమంటాం? థ్రెషోల్డ్ ఫ్రీక్వెన్సీ అంటాం. If more than threshold frequency is passed on it, that energy is nothing but that is converted into kinetic energy. Means the kinetic energy of electrons is given. It means the frequency of passed light is greater than the threshold frequency. So here what is the frequency is given? The frequency of passed light is 5.2 into 10 power 14 second inverse. The given light frequency, the light used for passing on the metal surface is 5.2 into 10 power 14 second inverse. We need to find threshold frequency of the metal. We need to find the nu naught. And there is information also given the kinetic energy of the electrons. So what is the kinetic energy of electrons? That is 1.3 into 10 power minus 19 joules. We need to find this. So what is the photoelectric effect equation? That is H nu minus, so H nu is equal to H nu naught plus kinetic energy. Here energy and nu minus nu naught is become kinetic energy by H. So we need to get the nu naught. So what will be nu naught? And we can write here the nu naught is equal to nu minus kinetic energy by H. Okay. Now substitute the values. What is the nu is given? Minus the kinetic energy is also given. So it is given in terms of joules. So then we need to take the H also in terms of joules into second. Minus 34. And here we get same 5.2 into 10 power 14 minus. So here we get 1.3 by 6.625. Here approximately we get 0.196 into this approximately becomes 10 power 15. Okay. So make it 1.96 becomes 10 power 14. Let's say nu naught equal to the threshold frequency equal to 5.2 minus 1.96. Just take the common point 10 power 14. Here threshold frequency is it becomes 3.24 as it is indicates the frequency that is second inverse. So this is the threshold frequency of the metal, means the frequency of the light must be 3.24 into 10 power 14 second inverse to eject the electrons. Already which frequency is used here in this experiment? 5.2 into 10 power 14 second inverse frequency of light is used. Means here frequency of light which is used is totally greater than mu naught. That's why there is a possibility of photoelectric effect. And extra energy, that is but extra frequency energy is used for the kinetic energy of the electrons. Okay, take it. Okay, see the next one related to photoelectric effect. Here it is given that the wavelength of the light falls on the metal. The wavelength of the light falls on the metal is 5000 angstroms. On the surface of a metal having work function is 1.9 electron volts. So these are the given informations. The work function means W naught, nothing but that is equal to H nu naught. Only nu naught is called a threshold frequency, or it is also known as critical frequency. So H nu naught means that is called a work function, or the minimum energy required to eject the electron from the metal's surface. So W naught is here, nothing but work function. So that is given as 1.9 electron volts, and given at the wavelength, the lambda is given as 5000 angstroms. Means that is 5000 into 10 to the power of minus 10 meters. So we never do the calculation in angstroms and even in electron volts. Here angstroms we transfer into meters. We also convert the electron volts into joules. So 1.9 electron volts means how many joules? 1 electron volt equals 1.6 into 10 to the power of minus 19 joules. And here we get 19 and 16. Approximately 3.4. 3.4 into 10 to the power minus 19 joules. So here there are two problems are given. We need to calculate the energy of photons. At first we calculate energy of photons. We know that energy of photons is called H nu. Here nu is not given. Nu means frequency is not given. Here only given term is wavelength. So convert it into in terms of wavelength. So that is equal H C the lambda. Therefore E equal the H the lambda is in meter. So H should be in joule into second. 6.625 into 10 to the power of 34. So velocity also must be in meters. So lambda is given as 10 meters. Here equal to 6.625. Here we know that where there is a particular calculation, 6.625 into 3 is approximately 19.875. This is minus 34. And make it is 5, then power 3 is become minus 7, it becomes plus 7. and then here finally we got this approximately we will get 4.9 something, so that is equal to 354, so approximately 4 we will get we may write 3.97 here. Minus 19 joules. So this is the energy of a photon. This is the energy of one photon. 3.97 into 10 4 minus 19 joules. So just with the value of this 5000 angstroms, with the help of that wavelength value, we calculated the energy of that photon. And next, the second problem is to find the work function. We need to find this work function. Okay. Sorry, here work function is given. We need to find the kinetic energy of photoelectrons. The photoelectrons means in photoelectric effect, the electrons ejected from the metal surface. We know that by passing a sufficient frequency of light on the metal surface, the electrons will be ejected from the metal surface. That electrons is known as photoelectrons. Okay, and we know the equation. What is the kinetic energy means? We know the general equation H nu equal H nu naught plus kinetic energy. And H nu means the energy passed, the energy of passed light. The energy of passed light is how much? We got 3.97. And H nu naught is the work function is also given in terms of electron volts, and convert that electron volts into normal joules. Already we converted them. We need to find kinetic energy, so which is equal to H nu minus H nu naught, and we get what is the H nu? The energy we calculated here minus H nu naught, which is a constant for a metal. This is 1.9. So electron volts. So we never do the calculation in terms of electron volts. If both are in electron volt, there is no problem. But already it is in joules. Already we converted it into joules. So the value becomes 0.57 into 10 to the power of minus 19, or it may be written as 5.7 into 10 to the power of minus 20. So kinetic energy must be in joules, as we are using the total energy terms in joules. So the kinetic energy of the electrons also in terms of joules. So it is the calculation of kinetic energy of ejected electrons. The ejected electrons generally treated as photoelectrons. Okay, take it. Okay, see the next one. Here, a photon of 300 nanometer. So wavelength is given. The wavelength of a photon, which is absorbed by a gas, again that re-emits two photons, means the one photon is absorbed by a gas, that is again re-emits into two photons. The gas only two photons emits in. So in which one is re-emitted with a wavelength of 400 nanometers. The re-emitted photons actually one absorb and the ప్లేస్ లో ఆ గ్యాస్ నుంచి 2 photons రిలీజ్ అయినాయి. It is in a 2 photon flow. The one photon is having wavelength 400 nanometers, and we need to calculate the energy of the other photon which is re-emitted out. Okay, so here the wavelength of one photon is given, the wavelength of the initial photon is given. So the first photon's energy we say it as the E energy total, and which is transferred, nothing but which is absorbed by the other gas one and released into 2 photons. So there is no change in the energy, there is no creation of energy. That E total is equal to E1 plus E2. Here we need to find E2. We need to find the energy of the other photon re-emitted. So say it is equation 1. We need to find this E2. Already we know the information about E total and E1. Now we find the E total. E total means the initial energy of the photons. Initial energy of the photons is equal, we know that h nu. The frequency is not given, h c by lambda. So E total is equal to the H value 6.625 minus 34 joules. C is taken in terms of meters per second. So here lambda is given 300 initial. Converting to meters, as we are taking in SI unit, joules meters per second, it should be in meters. Nanometers minus 9 meters. So here and here becomes addition minus 7 square, which becomes minus 7, becomes plus 7. So at last we get the total energy is 6.625 into 10 to the power of minus 19 joules. So we write here. So the total energy is obtained here is 6.625 into 10 power minus 19 joules. Next we need to find this E1. So we already calculated the E total, and to calculate E2 we need to get E1. Now we will see the calculation of E1 now. Okay. So for E1 also there is H. The formula is same for everyone. For every photon, that is H c by lambda. So that is even equal. And 0.8 meters per second. The lambda is given as 400 nanometers. So finally here we get same minus 34. This becomes 10 power minus 7 becomes 10 power 15 is 19. Here we get so that will be equal to, so finally we got E1 So approximately 4.9 something we will get. So this is the energy of the first photon, and here there we need to find the energy of this second photon. We need to find the energy of this second photon. Okay, with the help of initial frequency of light, we calculated the initial energy, which is positive, which is nothing but absorbed by a gas. Next, we calculated the re-emitted photons. In re-emitted photons, one photon's energy we calculated with the help of this frequency, but we need to find that E2 value by substituting these two values in equation 1. So by substituting this equation here, we can write that E2 is equal to E total minus E1. Therefore, E2 equal, here E total you got minus, so what is the E1? It's approximately 4.968 into 10 to the power of minus 19. So taking out 10 to the power minus 19, so finally we get the energy of re-emitted photon is so E2, the final answer is the 1.657 into 10 to the power minus 19 joules. This is the energy of the second photon, which is re-emitted. Okay, so it is the main important one. Here E total energy of the first photon, which is then transmitted to two photons, E1 plus E2. So if it is shifted to nothing but transferred into three photons, it may be written as E total equal E1 plus E2 plus E3. Okay, so this is the main key point in this problem. Okay. Okay, see the next problem, which is similar to the earlier one, but in this problem only we need to calculate the kinetic energy of the emitted electrons, where the frequency of passed light is given, the threshold frequency of metal is given. Just we need to calculate kinetic energy just simply by using photoelectric effect equation. So directly we will get the answer. Okay, right.